Okay, so we are getting into exponential functions and logarithmic functions here in a minute. So 6.1 in the textbook there is all about exponential functions, and then 7 is about logarithmic functions. That's going to be unit 4A and 4B from my website there. But yeah, to begin with here, what we're going to do, we're just going to kind of talk about what an exponential function even is, why it's different than just like a typical function, right? So I want to kind of remind you of like the types of functions I guess we've even done in school up until this point. So you guys have done stuff like this, right? Like if this would be a function. Y is equal to 2x plus 4. Okay, so that's a function. You can put a number in for x and you get a number out for y. This could have also been f of x, right? So that would have been a line, right? Then we moved on to doing, well, polynomials. So that was something like, I'll make it f of x this time. F of x is equal to x squared plus 2x plus 4. Right, and that looked different, right? That was our parabola that we were doing in the last unit there. So now what the difference here with exponential functions are, they're going to be something like this. So it's going to be f of x, and that's going to be equal to something like 2 to the power of x. So do you see how the variable is actually up in the exponent now? So that's going to change things, right? That's going to make our graphs look actually quite different here in a second. So here's the idea. Let's do some examples, and I think that'll make a bit more sense. So you guys with your calculators, no matter what kind of calculator you have, it would be worth it. You guys should type these into your calculators. I'm gonna do it just in this. It's called Desmos graphing calculator, just because it's kind of easy to work with, especially for video. But if you have your calculator, it's great. So you can type that in, and we can do this together. So all that this is for the window settings, right? This is like your x values were right there. So x would go from -5 to 5 in steps of 1, and then your y value would go -5 to 500, right? So that's your up and down in steps of 100. Okay, and that's really just so you can see kind of what's going on. But yeah, that it doesn't need to be exactly at the 500. You just got to kind of see up quite a ways there. Anyway, so if we do that, so if I type these in, so I'm going to type them both into my calculator here. We're going to have, I'm going to say y is equal to 10 to the power of x, and see what that looks like. So this right here is the general form for our graphs, right? Where, I'll make this a little bit smaller. So this is the idea. These graphs are always going to look like this, where they're like, starting low and going high. And I'll show you in a minute, it's going to go start high and then go low, but in general, this is the idea. So this thing will cross through right at 1, and then it goes up, and here's where this term comes from. It goes up exponentially, right? It's because it's an exponential graph. It goes up really steep. Like it drives up, like every little tick on the graph here makes a big difference the farther and farther up you go. Okay, so that's that one. So now let's type the other one in. So then we have y is equal to 2. I'm going to write the same way. So 2 and then 5 to the power of x. So we can see that changed things a bit, right? And one of the things that changed is where it crosses the x-axis. So this first one says, what are the x-intercepts? Oh, sorry, not the x-intercept. It changed where it crosses the y-axis. So the first one here, I was reading the wrong one. For number 1, what are the y-intercepts? Okay, so the y-intercept for the red one, right? That was just 10 to the power of x. That was this, right? It crossed right at the point. So here we'll say f of 1 or f1 of x, right? For that one, the y-intercept was at the point 0, 1. Okay, and then for f2 of x, that one happened. And then come over here and just click on it. It's a nice thing with this calculator. You can just click on it and it shows you instead of going into all your settings and everything. So that one happens at 2. So what's going on here? So 0, 2. Okay, so then this one says find them on your calculator, which we just did, and then it says find them mathematically. So let's find both these numbers mathematically and see how we got that. So let's do the first one here. So f1 of x. Let's figure out why that is the case. So I'm going to call it y instead of f of, yeah, we'll call it y1 is equal to 10 to the power of x. So remember where we cross the y-axis here? Well, that's going to be when x is 0. So if I just throw a 0 in for x, that should tell me what y is going to be. Okay, so y1, when x is 0 here, that's going to happen at 10 to the power of 0. And we have to remember what 10 to the power of 0 is, or anything to the power of 0. Anything to the power of 0 is always just 1, right? So y1, or f of 1, whatever, in this case, is equal to 1. Right? That's why we get this number, right? That's why it's crossing the y-axis at 1. Okay, so how is that different now from the next one? Well, if we had y2, right? So just looking at this one, and I put in 0 for x this time, we've got 2 times 5 to the power of 0. This is a little bit different because now only the 5 is raised to the power of 0, right? Only the 5 is raised to the power of x in general, right? This 2 isn't being raised to the exponent. So if I write this one out, this is really the same thing as 2 times, and then 5 to the power of 0 is 1. So in that case, y would be equal to 2. And that's why we cross the y-axis at 2 here. And that's always going to be the case. It's always this number out front that's going to be our y-intercept, right? So in general, the way that these are going to look is it's going to be y is equal to a times b to the power of x. And your a value, that value up front, like the 2 in that case, that is your y-intercept. Okay? And then your b value is really going to determine how fast the thing rises. That's going to tell you how fast the thing starts going up and up and up, like quicker and quicker. Okay? All right, so that's the gist of it. We're going to be doing lots with that. Okay, so now it says, what are the x-intercepts? I'm going to write DNE for does not exist, right? Your x-intercepts don't exist. And that's what happens down here, right? We actually get like an asymptote. This never does cross the line or the x-axis there, right? Describe the end behavior. So I'm just gonna keep this simple. Like you could say that it starts low in quadrant 2 and it's high in quadrant 1 rather. But I'm just gonna say it rises, right? And I'm just assuming it's from left to right, right? Just rises. Maybe we'll say that rises from left to right. Okay. Now describe the domain and range for both equations. So the domain in this case, even though this one looks like it is going to come to an end, it technically is going to go. It's going to go to the right forever. So and it's going to go to the left forever too. This would just be x is a member of the real numbers for your domain. So we'll say d dot dot. So x is a member of the real numbers. Okay, and then your range. Okay, well. This is a horizontal asymptote. This actually never does cross that line, right? Or touch it. It never actually gets to that point. So your range here is just going to be y has to be greater than 0. Not greater than or equal to, because it's not equal to 0. It can never be 0. It's just greater than 0. Okay, so there's your range. And that's really going to be the case for all of them, unless you're dealing with like a real world situation, right? Because like we did in the last unit, once you apply it to a real situation, then, if this is my time 0 right here, then all of this stuff back here wouldn't really exist, right? So it might change depending on the scenario. Okay, so explain why the two graphs are not the same. So I'm just going to do this verbally. I think we can probably tell. So 10x is not the same. It's not equal to 2 times 5 to the x. And the reason for it is because in this case, the x, it's actually 10 to the power of x, right? The 10 is actually being raised to the power of x. So that could be a 1, 2, whatever number you put in for x. And in this case, it's actually just the 5 that's being raised to the power of x, and the 2 is just hanging out front. This is just 2 times that, right? So they're different in that way. Okay. Okay, so now let's look at the next scenario here. So this one says, what are the y-intercepts for both? So we'll do it graphically again. So I'm going to type this one into my calculator too. So here I'll delete both of those. So we've got in brackets 1/2 to the power of x. All right, so that changed things a bit, right? And let's do the other one just while we're at it here. So 2 times 1/4 to the power of x. Okay, so how does that change things? Well, let's look at this first one again. So for this first one, f1 of x. Okay, so that one has a y-intercept. That's the green line one, was the one I made there, at 0, 1. So the same as the last one, right? Okay, and let's do a little different order. Let's find that one algebraically again. So let's say f1 of x. Actually, I'm going to say f0 or f1 of 0 is equal to 1/2 to the power of 0. So remember, all I did here, I just left it as f of x, but I put a 0 in for x, saying that everywhere that there's an x, I'm going to throw a 0 into the function. Just function notation, right? That could have been a y, right? Just like I did last time. But anyway, so f1 of 0 is equal to, well, it's like the same as last time. It's 1/2 to the power of 0. And it doesn't matter that it's just a half now, because anything to the power of 0 is just 1. Right? So that's where we get this from, right? It's going to be 1 at that point. Okay. Next one. So we'll say f2 of x. So for this one, that's going to happen at, well, that's the purple line there, right? That happens at, again, 0, 2. And doing that algebraically, we'll say f2 of, here, I'll write it all out again. f2 of x is equal to 2 1/4 power of x. Okay, so again, I'm going to say, what is f2 of 0, right? Which means I'm just putting 0 in for x. Okay, so in that case, that's going to be 2 times, and then 1/4 to the power of 0, right? So if I put 0 in there, here, I'll write it out. 1/4 to the power of 0, then that's f2 of 0 is equal to 2 to the power, or 2 times, and then 1/4 to the power of 0. That part of it is just 1. So this is really like 2 times 1. So that's just 2. Okay, so that's where we get this from again. So, or you could have just looked at this from the beginning and said, that thing right there, that has a y-intercept at 2, right? It's just the number out front, and it always will be. Okay, so yes, there's my y-intercepts. Now it says, what are the x-intercepts? Again, does not exist. Okay, and then 3, describe the end behavior. So then it's falling from left to right. Okay, and what's the difference here? Like, why are these ones falling? It might be worth actually just throwing a number in there so you can kind of see. Let's play around with this a little bit. So in this case, let's look even at the first one here. So if we had that f1 of x1, right, was, what did we say that was? 1/2? 1/2 to the power of x. Okay, so if I throw in, I already threw 0 in, right? I knew that this crosses at 1. But let's throw the number 1 in. If I said f1 of 1, so that'd be 1/2 to the power of 1. Okay, so at the point when x is 1, y is going to come out as a half, right? So that kind of makes sense. That's in our graph, right? When x is 1, y is a half. kind of hard to get exactly there. Yeah, 0.5. So I can see it on that graph, right? And then if I threw, here, we'll do it again, f1 of 2, right? So if I throw 2 in for x, then that would be 1/2 to the power of 2. Okay, well, that's going to be 1/2 squared is the same thing as a quarter. And that's what would happen here, right? So when when x is 2, y would be a quarter there. It's coming up wrong because it's going in the wrong graph there, but that's the idea there, right? Oh, sorry, when x is 2, 2 is right here. So that's a quarter, like right there. Yeah, on the green one, but they can't get to it. Yeah, there we go. Anyway, you get the idea, I think. Okay. Now, what about the other way? What if I go like on this side of the graph, right? To make sense of this, what's happening over there. So let's say if I put like -1 in. Okay, so if I put in f1 of -1, so just putting in like -1 everywhere that there's an x. So that would look like this. It'd be 1/2 to the power of -1. So f1 of -1 is equal to, do you remember what negative exponents do? Those negative exponents actually just flip this guy around, right? It's a reciprocal. So -1, when x is -1, flipping those things around, that's 2. Okay, see if that makes sense. So if I go over to -1, which is here, right? X is at 2. So y is at 2. So when x is -1, y is at 2. Okay, and the pattern continues on that way. Okay. Now, describe the domain and range for both equations. So the domain, it's going to be the same as last time. The domain is still going to be x is a member of the real numbers. And the range is still going to be y has to be just greater than 0. Okay, so how are these two graphs different than the two graphs on the opposite side of the page? Okay, so it's really these, right? Do you see the difference between this one and this one? So if your number, your b value, like we had before, is less than 1, but greater than 0, right? So like some kind of fraction in between, some kind of decimal in between, then it's going to be falling. You're going to get this falling graph that we have here, right? But if you've got like a number, like any other number, if you've got like a big number like 10 or anything bigger than 1, then you're going to get a graph that's climbing, right? That's going to be going up like our first one there. Okay. And then, yeah, I kind of explained this one already with like the negative exponent and how that changes things. So yeah, that's pretty much it. Before we get going though, what I'm going to do, I'm going to show you guys your homework questions and just make sure that you can like type it into the editor properly. Okay, so start over here. So this is going to be the assessment you guys do. So like, for example, this one is saying, what's the temperature after 10 minutes? I'll give you a hint. That would be the same thing as saying f of 10, right? So you would be putting 10 in for t. Make sure when you put in your calculator, though, that you're putting it in pretty much like this, right? Because the t, like the 57, has nothing to do with the power here. Like it's only 0.96 that's being raised to the power of t. So just careful when you put that in. Okay, this one looks super confusing, but a bunch of answers are going to be the same. So I was saying, oh, I didn't have it on there. So anyway, it's your y is equal to ab to the x, right? So your initial value would be your a value. So like in this one, 900, right? That's going to be your initial starting point. That would be like your y-intercept, right? When you get to these ones though, domain and range for these questions, I'll make sure you guys put these in right. I set these up so that they're like inequality questions. So a lot of your info will be here, right? So in this case, let's say domain, or quite often they're going to be all the real numbers, or I said a member of the real numbers. That would be this one. So this is what the answer would look like for that one. Okay. And then the range, I already typed that in before. Your guys won't be filled in, but it would look something like this, right? So again, you'd have to type in y because range is dealing with y. And it says it understands whether or not it's a valid inequality or not. So right now it's y, and then I got to go over to the inequality signs and use the right one, right? So in this case, it'd be y is greater than 0. And then it'll tell me, yep, that makes sense. It understands that. Horizontal intercept. And it says write it as a point. So that would be something like this, right? Zero, like 6, 0. So make sure you type it in kind of like that. And then vertical intercept, so something like this. Or if it doesn't apply, then you'd write DNE, which you can also click right here, right? You can either type in DNE or just click the button for it. And then the equation of the horizontal asymptote, an equation looks like this. It'll be y is equal to some number. And then for this one, yeah, just type it in. Okay, so that's how you type those ones in. Okay, so for your domain and range, you guys will be fine on those. Now, when you guys get to these ones, I set up a bunch where you can graph them, like actually graph the equation. And the way that this one works, so we're supposed to graph this equation. So it's already set up for an exponential function that has a horizontal asymptote at 0, which in 30-2, they really all will. The way this is going to work is if I'm going to plot my y-intercept first. They call it the vertical intercept. And my vertical intercept in this case, well, that's going to be 5, right? That's that number out front. And you could also think about that as if I put 0 in for x, then that would be 2 to the power of 0, which is 1. And then 1 times 5 is 5. So my first point would be right there, right? And then you can see as I plot my second point, it changes the way the graph looks. So if it was me, I would go over to the point when x is equal to 1, right? So when x is equal to 1, so if I put a 1 in for x there, then that would really be 5 times 2 to the power of 1, which is really just 5 times 2. So this next point would be at 10. Okay, so that's the way it should look. And then it says identify the vertical intercept as an ordered pair, so that's the y-intercept. So that would be at, you type it in like a point, 0, 5. Okay, and I did it right. All right, so I think that's it. And then they'll all be kind of similar to that. So let's double check here. There's no funny ones. Oh yeah, sorry. This one's a little bit funny too. That might throw you off. It just says graph y is equal to 2x, and you can just move this slider around. So get it to the point where it's 2x, and that's kind of it. It's kind of like an easier one. But then it says type it in using function notation. That would be typing this in as function notation. And that's it. You're just kind of retyping this in again. Okay, so it's kind of getting you used to typing in function notation. Okay, and then that should be good. Yeah, I'll let you guys try these out for yourself. So, and that there.